Hello everyone, so my name is Mlutra Enoch and we are going to do together CH110, the continuation for part 1. So this is part 2 calculation. We are answering question B on stoichiochemistry. So the question reads, when 12.10 grams of butyl ether, a compound of C, H and O, are completely bent in an apparatus of 30.1 grams of CO2 and 14.8 grams of H2O are formed. What is the empirical formula of the compound? So this question is under combustion analysis, and you have to be very careful and pay particular attention when you're answering this kind of question. So we start. So they are saying a compound having C, H, O, Z reacted with the oxygen. So this process is what we call complete combustion. When complete combustion takes place, the release of CO2 plus H2O is produced. So one thing that you should bear in mind is that you have to find the mass of what? Carbon, hydrogen and what? Oxygen. Now the mass of carbon is determined from carbon dioxide, and then the mass of what? Hydrogen is determined from H2O, that is water. And then for oxygen you have to add the mass of that and that, and then the total number you subtract it from the total mass that is given to you. That will be the what? Oxygen, the mass of oxygen. So we start. So first thing that you are going to do is to find the mass, molar mass of molar mass of CO2. So molar mass of CO2. So one atom of carbon times 12.01, that is just the number that is found on top of carbon, the relative atomic mass. Add it with the 2 atoms of oxygen, multiply by what? 16.00. So when you tabulate everything on the calculator, you're going to obtain 44.01 grams per mole. Now in the question we have been given the what? The mass for carbon dioxide there, so which is 30.1 grams. So what you're going to do is that you're going to, that same mass is going to help you to determine the mass of carbon. So it will be 30.1 grams over 1 times, so 44.01 grams of what? Carbon dioxide is equivalent to 1 mole of CO2 there, that is. So what is going to happen is that that one will go, that one will go, multiplied by what? So one thing that you should bear in mind is that in carbon dioxide there is 1 mole of what? Carbon. So in carbon dioxide, so 1 mole of carbon dioxide, there is what? 1 mole of carbon. So that one goes, that one also goes, times, so 1 mole of carbon, that is 12.01 grams of what? Carbon. That one cancels, also that one goes. So when you just tabulate or punch everything on the calculator, you're going to obtain 8.21 grams of what? Carbon. So that is the mass for what? Carbon. The second thing that you're going to do to find the mass of hydrogen, you're going to find first the what? The molar mass. Molar mass of molar mass of H2O. So 2 atoms of hydrogen times 1.01, add it with 1 atom there times the relative atomic mass, that is 16.00. So when you just tabulate everything on the calculator, you are going to obtain 18.02 grams per mole. So from there, what you are going to do is that you have been given what? The mass of H2O that was formed. That one will assist you in calculation of what? The mass of hydrogen. So that is 14.8 grams over 1, cross multiply with it. So 18.02 grams of H2O is equivalent to 1 mole of H2O. So that one goes, that one also goes, multiplied by. So one thing that you should bear in mind is that there is 2 moles of hydrogen in what? In H2O. So that is 1 mole. So that one goes, times, what about in 1 mole of hydrogen? There is how many what is the mass? So there is 1.01 grams of what? Hydrogen. Then there cancels, there you cancel, and then you tabulate everything on the what? Calculator. You're going to obtain, so you are getting 1.66 grams of hydrogen. So from there, what you're going to do is that to find the what? The mass of oxygen. So the mass of oxygen, you are going to get the what? The total mass that you have been given of that compound, which is 12.10 grams. 12.10 grams, subtract, and then you add the 2 masses, that is of hydrogen and carbon, which is 1.66 plus 18, that is 8.21. So when you tabulate everything on the calculator, you're going to obtain, so you're going to tabulate, when you tabulate, you're going to obtain 2.23 grams of oxygen. So this is the mass of oxygen. So from there you can go ahead and what? Find the empirical formula. So you have carbon, hydrogen, and oxygen there. So what you are going to do, so the mass of carbon, that is 8.21 grams, hydrogen 1.666 grams, oxygen 2.23 grams. So divide by their what? Relative atomic masses. So for that one, which is 12.01 grams per mole, that one, that is 1.01 grams per mole. That one for oxygen, that is 16.00 grams per mole. So grams goes, there you cancel, and then when you divide you're going to obtain, so when you divide you're going to obtain 0.6836 moles. Then there you're going to obtain 1.6436 moles. There you're going to get 0.1394 moles. So when you reach at this stage, what you're going to do is that you divide by the smallest number, which is 0.1394 moles. 0.1394 moles. Also that side 0.1394 moles. There you cancel those moles, you cancel the moles, and then there you're going to obtain 1. There you're going to get 11.79, and then there you're going to get 4.90. So from there you're going to round off. So there are certain rules that you should abide to. So if it is within the range of 0 to 4, just get the way it is. And then if it is 5 to 6, you have to multiply by the number that can give you a whole number. And then when it is 7 and above, just round it off. So from there I'm going to round it off, that is it's going to be 5, and then there is going to be 12, there I see 1. So there our empirical formula, that is C is equals to C5 H12O. So this is the final answer. So please don't forget to share and subscribe, so that whenever I post the new video you are able to see and watch. See you in the next video.